Now we want to look at determining which of the following vectors are parallel. Okay, so let's see how we can do that. First of all, let's think about vectors in a different way. So let's think of a vector, a general vector A, as a triangle, as a right triangle, right? It has the A1 component and the A2 component. Now, if I were to scale this triangle by an amount, or if I were to scale this vector by an amount, let's say 2, then I'd have this vector over here, right? I'd have A, but now my A has become 2A. And this would be this overall vector right here. Now let's see what happens to the sides. What do you think this side is going to be? And what do you think this side is going to be? Pause for a second and think about it and see if you can reason it through. Okay, I'm assuming you did that. So let's look at these two right triangles form. We have a right triangle, the big right triangle, and the small one, and they have this angle in common. So we know that they are similar because they have two angles that are the same, which makes the third angle the same as well. And what does it mean that two triangles are similar? It means that each respective side is proportional to one another. So the hypotenuse of A is proportional to 2A. And what does it mean for something to be proportional? It means that it's scaled by some factor. And in this case, this factor is 2. And that is the same. The scaling factor for similar triangle is the same for all sides. So 8, 2, the vertical component of our bigger vector is going to be 2 times the vertical component of our original vector. And that is the same for this one right here. It's going to be 2 times A1, right? Now, why did I say all of this? Well, because think about it. If we are multiplying a vector by a scalar, we can make it longer, we can make it shorter, we can flip it and make it shorter, flip it and make it longer, but that's it. We're constrained to this line over here. So if I know that I can represent two vectors or one vector as a scalar multiple of the other, then I know I'm going to be on the same line, which means I'm going to be parallel. And another reason to think about it is that these sides of those triangles will always be proportional, so this angle will always be the same, so those two vectors will always be parallel. So now they're asking, determine which of the following vectors are parallel to the vector A. And the book does vectors with the bold. I like to include an arrow on the top because the bold is sometimes hard to distinguish. So to have a vector that is parallel to this, first of all, why don't you give me a vector that is parallel to this? Well, think of any number and multiply it by both components. And that's going to be a vector that is parallel to A. So we can say 1, and we can say 4i plus 6j hat. That's parallel. Well, that's in fact not just parallel, it's also the same vector. But let's say 2. So then you'd have 8i hat plus 12j hat. Well, that is parallel because I just multiplied by 2 both sides. So I kept this relationship, this similarity relationship over here. So this angle that I did in orange is the same. So following that logic, why don't you go ahead and do A through F and see what you would get. And then you can check back and see how I do it. Okay, I'm assuming you did that. And now, let's see. Is negative 4i and negative 6j hat parallel? Well, is there a way to go from A to this with a single scalar? I think there is. negative 1. If I multiply 4 times negative 1, I get negative 4. And if I multiply 6 by negative 1, I get negative 6. And so we're confident that it's similar and that the vectors are parallel. And if you graph it, indeed, you'd have 4 and 6, a vector A here, and this other vector here. Now, if you were to translate this vector, boom, 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 you translate it over here, you would see that it's parallel. Now, let's see. So this one is parallel. Determine which vectors are parallel. This one's a parallel vector. How about B? Okay. Is there a way to go from 4 to negative 1 with a single number that is the same needed to go from 6 to 3 halves? Well, how would you go from 4 to negative 1? I would personally divide or multiply by negative 1 over 4, because then the 4's would cancel out and you'd get a negative. Well, if I multiply by negative 1 over 4 to the 6, do I get 3 halves? Well, let's see. Negative 1 over 4 times 6, that's the same thing as 3 and 2, negative 3 halves. Indeed, I do. And so I know that this one is also a parallel vector to our original vector. So we got these two. Okay, now is there a way to go from 4 to 10? Yes, I like to think of it this way. Think of it like this. If I multiply 4 times 10 over 4, meaning the thing that I want to cancel out is in the bottom and the thing that I want is in the top, then those will cancel out and I get a 10. But now, can I do that and get the same answer here? Let's see. If I say 6 times 10 over 4, well, that's the same thing as 3 times 10 over 2, which is 30 divided by 2, which is indeed 15. So this one is also parallel. Let's see letter D. Okay, this one's a little bit different because we don't have yet a single I hat and a single J hat. Could we get to that? Well, of course we can. We just have to distribute this 2, distribute this 3, and then add the similar components, quote unquote, similar together. So that would be 2 I hat minus 2 J hat minus 3 over 2 I hat plus, okay, let's see, we have 3 times 5, which is 15 divided by 12 J hat. Okay, and then we can simplify this, right? These are both divisible by 3, so this would be a 5 and this would be a 4. So now we can add 2 minus 3 halves together for the I hat, and then we can add 5 fourths minus 2 for the J hat. And what would this be? Well, we'd have to do a common denominator. So what type of 1 can I multiply 2 by in order to have a denominator of 2 and being the same value though? Well, if I multiply by 2 over 2, then I get 4 over 2 minus 3 over 2. And notice that multiplying by 2 over 2 is just like multiplying by 1. In fact, if you simplify that fraction, you'd get 2 again. Same deal here. Well, what can I multiply 2 in order to get a denominator 4? Well, if I want a denominator 4, I can multiply by 4 over 4. That's still like multiplying by 1. So the 4 in the numerator times 2 would be an 8, and the 4 in the denominator would be a 4, and that would be my J hat. Now I can do my subtraction, and it would be 4 minus 3, which is 1, the denominator stays 2, I hat, plus 5 fourths minus 8 fourths, that would be negative 3 fourths, J hat. Okay? So let's see, is there a way to go from 4 to 1/2? Well, if I do 4 times 1 over 8, that's going to be 1/2. But now, if I multiply 1/8 times 6, do I actually get -3/4? Well, without even doing it, you see that this would be positive and this would be negative. So we cannot say this, which means that these two are not parallel. And if you had some doubts, you could go ahead and graph them and see if they are parallel or not. And let's think about it. If this is 1/2, so say this is 1, 2, 3, 4. So 1/2, if this is 1, this would be 1/2, right? And then say this is 4 as well, but we're in the negative direction. So this would be -3/4, because this would be 1 again, this would be 1 divided by 4 parts. And so then we'd plot this guy right here. Now remember, the other one, the original one, was a 4 and a 6. So it's not to scale, but it was pointing in this direction. You see that these are not parallel. So we're confident about that now. Now let's do E. So E is 8/12. Is there a way to go from 4 to 8? Yeah, we can multiply by 2. And if I multiply 6 by 2, do I get 12? Yes. So this is parallel. And I invite you to graph it if you have a doubt, because you can always make sense of it by graphing it. This one is similar as before. We have to develop it. So let's develop it over here, and let's say 5i minus 7i plus j, and these should all have a hat in my opinion, minus 4j hat. Well, what is this? Well, this is going to be -2i hat, and this is going to be -3j hat. So, is there a way to go from 4 to -2? Yes. If I multiply by times -1/2, -1/2 times 4 would be 4 divided by 2, which is 2, and then the negative in front. Now, if I multiply 6 times, if I multiply by -1/2, do I get -3? Indeed I do, which means that this is also parallel. So they ended up having a lot of parallel ones. I was not expecting to have all of those. So that's how you do it.